Okay, let's move on to unlike fractions. To add or subtract fractions with different denominators, you need to first rename the fractions using the least common denominator, or LCD. Add or subtract as with like fractions, and then, if necessary, like with like fractions, simplify the sum or difference. Before you can add two unlike fractions or fractions with different denominators, you must rename one or both of the fractions so that they have a common denominator. Now, when we move to our examples, starting on page 292, with example number 1, you're going to see that they have two methods over here on the left. Method 1 is to use a number line. I'm just going to tell you right now, you do not want to be drawing a number line every time you do a addition or subtraction problem with fractions. So we're not even going to bother with method number 1. We're going to actually do method number 2. So you would start out by first taking your problem 1/2 plus 1/4, and like I showed you with like fractions, I want you to rewrite it vertically. This is going to help you when you do find a common denominator for these fractions. We can't add 1/2 and 1/4 together because they do not have the same bottom number. If I were to say, how many spoons do you have if you have 2 spoons plus 4 forks? You would say, well, I only have 2 spoons. I say, okay, well, how many forks do you have? I only have 4 forks. Well, what if I wanted to add those together? What would you have? Would you have spoons? Would you have forks? Would you have sporks? What would you have? Well, we would have to come up with another name that would put the two things together. We might say we have 6 utensils. That new name is kind of what we're doing here. We're kind of taking our halves and our fourths, and we're going to come up with a common name. And in this case, it would be fourths. Why? Because the smaller denominator divides equally into the larger denominator. So I'm not going to have to change my fourths. I can leave that the same. But I am going to have to multiply the top and bottom of 1/2 by the fraction 2/2 to get 2/4. Now that we have a common denominator, we can go ahead and add our fractions together. 2/4 plus 1/4 equals 3/4. So we must first find a common denominator. Let's do one more together. Let's do letter B. I like B because it's a little bit different because it has those double signs in there. So 9/10 plus -1/2. Whenever we have a double sign, the first step always is to get rid of that double sign. So you take your positive and negative, and it becomes a negative. So I have 9/10 and -1/2. Hopefully you see that that's going to be a subtraction problem. I need to find a common denominator. I ask myself, does my smaller denominator divide into my bigger denominator? And it does. So I'm going to multiply 1/2 by 5/5 because 2 times 5 will equal 10 and give me a common denominator. 1 times 5 equals 5. I just drag my 9/10 over, and I also need to make sure I drag over any signs. So this negative needs to come over here so I don't forget that I will be subtracting on this problem. 9/10 minus 5/10 equals 4/10. But wait a second, we can't stop there because both of those numbers are even. I know that this can be simplified. So I will divide top and bottom by 2 and get 2/5 as my answer. Go ahead now and complete the other 3-lettered problems on this page. Let's take a look at example number 2 on page 293. Again, we want to write the problem first on our page, and then we're going to do some things to solve it. We have three things that we got grouped together, and you will notice that there are parentheses. Well, with addition and subtraction, I can actually make addition and subtraction commutative by making sure that with each of these terms, I include the sign. So if I think of this as negative 3/4, positive 5/9, and positive 7/4, I can ignore the parentheses, I can ignore the order that they're written in, and rearrange them. I'm going to show you why that can benefit you. If I take 7/4 and negative 3/4, you can see that they already have a common denominator. So I've gotten those out of the problem and I put them down here, and you can see that that's just an easy, simple like fraction subtraction problem. And what happens is I get 7/4 minus 3/4 equals 4/4. Well, that's just equal to 1. What I have left then is plus 5/9. I don't need to do anything with that because what's 1 plus 5/9? 1 and 5/9. So sometimes rearranging the order of my numbers can really make a problem simpler. Let's see if the same thing happens on E and F. Why don't you give those problems a try? Let's take a look at example 3. It says negative 2/3, negative 1/2. I want to point out here that sometimes this book, when they write their negatives, it becomes too close to the fraction bar and it looks like it's just a really long fraction bar, but that is indeed a negative sign. If you see that fraction bar where it's extended to be too long, it's a negative sign. So just beware that sometimes I think they forget to put a space between there when they typed it up. So make sure that you know that that is a negative 2/3. Again, we're not going to use this method 1 with the number line. We're just going to go on to method 2. Take a look at this problem. Hopefully you see right away, because we've been doing integers and positive negatives for so long, that these two numbers have the same signs and you're automatically going to be thinking about adding them. When we do add them though, we are going to again write them vertically, and I'm going to go over here because of all this extra stuff that's written in here, and write negative 2/3, negative 1/2. I'm going to know that I'm going to add them, and now I've got to look for a common denominator. You will notice that the 2 doesn't divide evenly into the 3. So our common denominator isn't going to be one of our denominators that we already have. Instead, we're going to have to start looking for a denominator that both will divide into. My recommendation is to start counting by the largest one. If you start counting by the largest one and trying to divide the smaller one into what you get, eventually you'll find it. So if I count 3, 6, does 2 divide into 6? Hopefully you said yes. So my common denominator is going to be a 6. I'm going to have to multiply both of my fractions by something to get a 6 on the bottom of each. What do I multiply times 2? 3. So I'm going to multiply this fraction by 3/3 and get 3/6. What do I multiply by 3 to get 6? Well, that's 2. So I'm going to multiply this fraction by 2/2, and I'm going to get 4/6. Don't forget that these are both negative and bring my signs over. So negative 4/6 and negative 3/6, same signs, so I add and keep the sign. So I get negative 7/6. Well, hopefully alarms are going off in your heads right now going, the 7 is bigger than the 6. So we have to change that from an improper fraction into a mixed number. 6 goes into 7 one time. Don't forget your negative sign. -1 with 1 left over, because 7 minus 6 is 1. And then our 6 remains on the bottom. So -1 and 1/6. Why don't you go ahead and take a look with me at letter I? We'll do I together, and then you can do G and H on your own. It says 1 minus a -2/5. Well, there's one of those pesky double signs, and whenever you have one of those, you want to get rid of it right away. So a double negative becomes a positive. So when I rewrite this problem, it's going to become 1/2 plus 2/5. 2 does not divide equally into 5, so I'm going to start counting by 5. I'm going to go 5, 10. Does 2 divide into 10? Sure it does. So 10 is going to become our common denominator. And we're going to have to multiply both fractions by something. What do I multiply times 5 to get 10? 2. So this will be 2 over 2. I have to multiply 2 times 5 to get 10. So this will be 5 over 5. Up here I get 1 times 5 is 5. Down here I get 2 times 2 is 4. Don't forget they are both positive, so we are going to be adding them. 5/10 plus 4/10 equals 9/10. And of course I want to stop and ask, do I have to simplify? And of course the answer here is no. So 9/10 is my answer. Why don't you give G and H a try on your own? Here is example 4 on page 294. This is our last example. Let's read it. It says, use the table to find the fraction of the total population that has type A or type B blood. So if we're trying to find the population that has type A or type B, what are we going to do? Are we going to be subtracting them to see which there is more of? Or are we going to be adding them to get a total? Well, hopefully you just said total. It says total population that has A or B. So hopefully you said we're going to be adding fractions together. So we're looking only at this part of the table since we're only concerned with those that have A and B blood types. And we already said we're going to be adding those together. So we'll have 21 over 50, those that have type A, and 1 over 10, those that have type B. Do we have common denominators? No. So we ask ourselves, does my smaller denominator divide into my bigger denominator? And yes, 10 will go into 50. So we're only going to have to change 1/10. We will not have to change 21 over 50. We'll just be able to drag that over. So what do I multiply times 10 to get 50? But of course, 5. And 5 times 1 is 5. 5 times 10 is 50. We can now, because we have common denominators, add our two fractions together, and you get 26 over 50. And of course, when we get our answer, we need to stop and think, is that simplified? And hopefully you're saying, no, those are both even numbers. We need to divide by 2. So divide top and bottom by 2. 50 divided by 2 is 25. And 26 divided by 2 is 13. 13 is a prime number and will not divide equally into 25. So our answer here is 13 out of 25 people have A or B blood. All right, I think you're ready to try some problems on your own.